Welcome to Logs Lesson 3. We're going to be looking at the laws of logarithms. Each of the laws of logarithms has a parallel in the laws of indices. That makes sense because, as we already know, powers or exponentials and logarithms are essentially inverse functions. So we're going to see a similarity, but perhaps also an inverse property with these laws of indices. Make sure that you are familiar with them and confident with manipulating things and transferring backwards and forwards using those laws of indices. And we're going to try and do the same with the laws of logarithms. I'm not going to prove them for you now, but you do need to be able to prove them, and you certainly are able to prove them. The proofs are within the Khan Academy videos and in the textbooks. Make sure you have a go at trying to understand those and trying to do them for yourselves. In fact, some of the textbook, some of the questions are prove this logarithm, and it gives you an idea of how to do that. The first few that we're going to look at are essentially just properties rather than laws, things that we've already looked at before. So the first one, let's remind ourselves what a logarithm means. Firstly, this means this is the power that we have to raise a to get 1. So a to the power 0 is 1. And that's exactly what we see over here with this law of laws of indices. And we've seen this one before. Similarly, we've seen this one before. This is the power that you have to raise a to get a. Well, this is equal to 1. And again, we're familiar with that. This one's a little bit different, but again, links to things that you already know about indices. We know that a to the power of minus 1 is the same as 1 over a. And that's exactly what this statement is saying. This is the power that we have to raise a to get 1 over a. A to the minus 1 is 1 over a. That's exactly what we see here. And this one is a funny one, but it's just kind of obvious. It's a tautology, really. So this is the power that we have to raise a to get a to the x. Well, it's just going to be x. X is the power that I have to raise a to get a to the x. It's just obvious. But it's really important because this is what we were looking at last time about inverse functions. Here we can see the logarithm to base a of a to the power of x cancels each other out. It just leaves us with x. So this idea of inverse functions is really, really valuable. So the next three are the key laws of logarithms that you'll use to manipulate questions. And again, they have analogies over here. So let's have a look at the first one. This I'm going to call the addition rule. And it basically says that if I have a logarithm, base a or any base, of a product of two things, then that is equal to the logarithm of the first plus the logarithm of the second. And you can see the link there to this law of indices. Okay, a to the power of x plus y equals a to the x times a to the y. They're linked and they have a relationship. Similarly, with this, the law of subtraction over here, we've got something similar over here for the logarithms. If I divide two values and take the logarithm of them, and that's the same as the logarithm of the first, subtract the logarithm of the second. And then the third key rule is what I'll call the power rule. And if we take the logarithm of x to some power, then we can just multiply the logarithm of x by that power. Now this is related to this rule here, because if we made this log a of x times x, that would be essentially x squared, and on this side we get log x plus log x, i.e. 2 lots of log x, which is what we get down here, 2 lots of log x. And we can extend that rule, x times x times x, we can get log x plus log x plus log x. And we can see that this rule would work for any integer, but actually this rule works for any value of m, and allow you to think about how you might prove that. You need to be able to go in both directions. So, we can convert log of x times y to be this expression, or we can go backwards to say the addition of two logarithms, we can multiply, we can go forwards and backwards. So let's put this into practice and see what we get. I highly recommend having this page written in your notes somewhere that you can have in front of you whenever you're working on logarithms. It's very easy to get confused and mixed up with the laws of logarithms. And initially having them there in front of you will just help you gain a fluency that will help you to get it into your memory, so that in the exams you won't need to have it written in front of you. But I find it, while learning, having it right there just helps to stop any confusions. Right, let's put this in practice. So here, the question is asking us to simplify this expression. We're going to use the fact that x, or we're defining x to be equal to log of a, y to be equal to log of b. And we can use that to rewrite this in terms of x and y. So first of all, we want to do this one step at a time. If we try and use too many rules at once, we're going to make some mistakes. So notice here, I've got something divided by another thing. I'm going to treat this as one item, and I'm going to treat this as a separate item. And so because we're dividing, we can use the subtraction rule. Here, log, it doesn't have a base written there, so this must be log to the base 10. So it's saying this is the power that I have to raise 10 to get 10. Well, 10 to the power 1 is 10, so this must be 1. And here, we're going to be, I'm going to treat this as one item times another item. So let's use the addition rule here to separate those two. Here we've got a minus 1. Finally, here we're going to use the power rule. We're going to be able to move this power to here to get 2 log of a. Nothing else changes. But we now have, this is x, this is y, according to our definitions at the beginning of the question. And there's our answer. That should now allow you to answer the following questions down here in exercise 7B. But remember, you might need to be able to go backwards. So they might give you a question that looks like this. And you might need to be able to write it as a single logarithm, i.e. working backwards until you've got a single logarithm. So let's have a look at that and see how that might be useful, this time in the context of solving equations. So here, in order to solve the equation, because we've got 2 logarithms essentially, we need to rearrange it so that it's written as a single logarithm, so that we can then do the inverse or get rid of that logarithm and find the logarithms. So notice we're adding these 2 logarithms, so that must be the same as the logarithm of this x multiplied by this x plus 4. So log to the base 2 of x times x plus 4. The right-hand side of the equation hasn't changed. Now here we could get rid of this logarithm because there's only one of them now. A bit like if you had a sine of x times x plus 4, you would do inverse sine. Here we could do inverse logarithm. So the inverse is raising e to the power of both sides of the equation. So here I've got e sort of 2 to the power of the left-hand side equals 2 to the power of the right-hand side. And because those are inverse operations, they will be a cancel. I'm just going to get left with x times x plus 4 equals 2 to the power 5. Another way of thinking about it, though, is just what does logarithms mean, the definition. So we could say instead, this is the power to which we have to raise 2 to get this. The answer is 5. So 2 to the power 5 is the thing inside the logarithm bracket. So we can make that step in one if we want to. Now we can just rearrange to get a quadratic and solve as you already know how to solve quadratics. Here's another, but similar, very similar. Like it looks different because this time the unknown is in the base of the logarithm, but the practice is exactly the same. Notice we've got the addition rule, so we're going to combine these 2 logarithms to give us logarithm of base x of 4 times 16, which is 64. or the right-hand side hasn't changed. And now we can use our understanding that this means the power that we have to raise x2 to get 64 is 3, so x to the power 3 is 64. Or you can use inverse if you want to. And then we can just now solve this to give us that. So you should now have a good chance of being able to answer the rest of the questions in exercise 7B. Remember to read the pages in the book. The explanations are very good, but it takes time to read maths. You might only take 30 seconds or a minute to read a page of a novel, but it takes a lot longer, 10 minutes or so, even just to read a few lines of mathematics. So take your time to read it, reread it, always asking yourself why. Use the examples to help you, and I'm sure that